Hello. Okay, this is an attempt to explain how you get all these dimensions. There is dimension 1, dimension 2, dimension 3, 4, 5, 6. Okay? And then the holes that are inside the plate is dimension A, dimension B, dimension C, and dimension D. Now, for those of you who are here, you can go ahead and note down on this page what the value is. So you need not be thinking about it again. But you need to understand this, okay? And this drawing is required so that you can go about marking out your plate and you can start machining it, alright? Now, the very first dimension that I want to talk to you about is dimension 1. Dimension 1 is, I'm going to try and draw it here. Is this rectangle? Okay. And then there's 1, 2, 3, 4. We just draw these 6 holes first, okay? 1, 2, 3, 4, 5, and 6, okay? And I'm tackling dimension 1, 2, 3, 4, 5, 6 first, alright? Before I talk about the 4 holes that are inside here, alright? These holes, 6 holes, are actually for your side plates, the catapult side plates, and for the motor plate, okay? Each plate has got 2 holes, alright? Each plate has 2 holes, and the motor plate here has 2 holes also. So if you look underneath this catapult, you will see 6 holes for the screws, and the screws going there. Okay, and that's what these 6 holes are for. Okay. Now dimension 1 is this dimension. Let me try to use a red marker. Dimension 1 is this dimension here. And they tell you that the width of your plate is 95 mm. All the dimensions here are in millimeters, okay? And here is 120 mm plus minus 2 mm. So we just assume that it is at the, maybe say 96 mm. Okay, we just assume. Now, what happens is that, what is this dimension that you can have or you should have? If you were to have your plate, right, your side wall flush to the edge of the plate, this side wall, the thickness of this side wall, if you were to look at your drawing, now let's turn to the side wall drawing, which is this drawing. It's 8 millimeters. You can see over here is 8 millimeters, right? And therefore, the center of this, it's not so nice. The center of this here, this dimension should be at least 4 millimeters minimum. Do you understand? Because the thickness of this wall is 8 millimeters. But generally what I usually like to do is I usually give it 5 millimeters. Okay? So you can put 5, you can put 4, but you shouldn't put 3. If you put 3, your side wall will be too far out from the plate. Any questions so far? This is your dimension number 1. Okay? So you can write it down now on your sheet. Now how about dimension number 2? Dimension number 2 is the distance between the 2 side walls. Alright? And it is this dimension here. Dimension number 2. Oh, hideous, good Lord. Dimension number 2, and this is the dimension that we are looking out for. Now this is going to be a bit tricky, right? This dimension is between, okay, let me talk to the video, between these 2 screws, right? The center of these 2 screws. You understand? Now how do we find this dimension? If you look at the catapult, the first hint that you know is that there is this thing called a stop bar. The stop bar prevents the catapult from firing and going past it. Okay? Now, what is the length of this stop bar? The length will help you identify what dimension 2 is. Okay? Can someone look at the stop bar drawing and tell me what is the length? I am now going to the stop bar drawing. Okay, what is this length here? What's the length of the stop bar? Can someone read the drawing and give me an answer? 64.5. Yeah, very good, 64.5. Okay, now, however, dimension 2 shouldn't be 64.5. What do you think should be the number? Because dimension 2 is actually the center of this hole to the center of this hole. So it's 64.5 plus a certain number. What do you think that number is? What do you think, class? I'm looking at other drawings. Drawing number 6. Yes, correct. So what do you think the dimension should be? Dimension number 2. Let's flip back to that stop bar. Hey, I'm not going to spoon feed you the answers you know. You need to work with me on it. What's the thickness of the plate again? 8, right? From the edge of the plate to the center of the plate, what would the distance be? 4 millimeters, okay? I say again, from the edge of the shaft, right, which is touching the plate, and from the plate to the center of the hole is 4 millimeters, right? So if it's 4 millimeters on one end and 4 millimeters on the other end, and if the length of the shaft is 64.5, what is dimension number 2? Sorry? 72.5. Very good, 72.5. Okay, so I'll write here 72.5. Now what is dimension number 3? Whoops. This is dimension number 3. And what is dimension number 3? Dimension number 3 is from the screw to the edge of the plate. From the screw to the edge of the plate. Sorry to the guys back there who can't see. Right? From the screw here to the edge of the plate. That's dimension number 3. Yeah. I need to flip it this way. Or you need to look at it this way to see. So is this. So what is this dimension. You can look at the side wall drawing to figure it out. Let's find the side wall drawing. I'm going to post this up on YouTube and I'm going to attempt to be a YouTuber. Maybe I might be lucky and become an I2E influencer. Yeah, did I just say influencer? Influencer, or whatever it is. Okay, if you look at this drawing, this side wall here, what do you think would be the dimension, the minimum dimension that it should be from this hole, the center of the hole? This is the mounting hole. These will be your mounting holes. Okay? And this is this width of the plate here. This width of the plate here is this width from here to here. So of all the dimensions, there are a lot of numbers here, right? Which number do you think would be most appropriate? If let's say I want to have the wall, this side wall, flush to the edge of the plate, what would be that number? Have to think, guys. Have to think. Any suggestions? You have all these dimensions here, and one of these numbers would be the correct answer. Which one? Okay, I think there are some. I think it's better if I pass the notes, and then later you return it to me so that you can learn better. It's not so effective. Here you go. Which number? Would it be 8 mm? Would it be 15 mm? 50 millimeters, 100, 7.5, 10, or 50? What do you think is the answer for dimension number 3? Sorry, say again. 5 mm. Where do you get 5 mm from? You don't think it's 5? Yes, it is not 5. The hints are the number for dimension number 3 is in this drawing here, and it's one of these dimensions. It can be larger than that dimension, but the minimum dimension it should be is here. It can be found here. Where would it be? 8. Sorry? 8. 8. This 8. Wrong. Very close, but not 8. 7.5. Ah, who said 7.5? Who? Oh, 7.5. Very good. Wow, the mask can really muffle. I don't know where the sound is coming from. Very good. It's 7.5 because this is the edge of the plate, and this edge of the plate here. Right? Imagine this is the plate here. This edge here is this edge where my finger is touching is here. You get it? And then the hole that is underneath is here. This mounting hole. So you can see that it's actually minimum 7.5. You can put 8 millimeters, it's okay, right? In fact, hey, I'll just put 8 millimeters, okay? So that you don't feel so bad. Right, 8 millimeters is fine. Right, 8 millimeters is fine. Here is 7.5. So, we have this distance. Now, what is this next distance that we have to find? Dimension number? Dimension number 4. Right, dimension number 4 is here. What is this dimension? You need to look at the side wall picture. The side wall picture, so you need to flip again back to that side wall picture. And this one is really, this one is a bit tricky. Alright? This distance here, dimension number 1, 2, 3, 4. Dimension number 4 is the distance between these two screw holes. Okay? Dimension number 4 is the distance between these screw holes that mount the side walls. Okay? And this is for this dimension here, the side walls. And I've got the side wall picture here. So I need to find this dimension from this center line to this center line. How do we do that? What is that number? 27. Wait, ah. 10, 15. Wrong.
35.
It's 35. Can you tell me how you get 35? Yes, very good. You take 7.5 here plus 7.5 here, you get 15 millimeters, right? And then you take 50 minus 50 minus 15, 15, and then you get 35 mm. Okay, so this is 35 mm. I think I'll put it in blue pen so that the video can capture.
That's 27, sir. 11 minus 8.
What? 35 is between the center of this.
Oh, okay, never mind.
Yes, correct. You can put it as 27 if, no, you still can't put it as 27. Right? But if you want to plus the 8, then you need to have a longer dimension. But we are going according to the drawing. Okay? Let me take a look at the video to see if they can see the numbers on the screen. Yeah, you can see quite clearly. Okay. Now, what is the next dimension? Class, am I going too fast? The next dimension is dimension number 5. Dimension number 5 is really shitty. I'll leave it for the last. Did I just say shitty? No, sorry. I shouldn't be saying that. Dimension number 5 is really tough. I'll leave it for the last. I'll explain it in the last. But let's look at this dimension here. Dimension number 6. Dimension number 6 is the motor plate. Is this small little plate over here, and we need to find the distance between the small little plates here. Okay? In case the bad people can't see, is this motor plate small one? 2 holes here. Okay? This is dimension number 6. Alright? Are you able to see? Very good. Now we have to look for that motor plate, which is here. What is this dimension here?
35.
What, very good. 35. And the reason why it's 35 is because same thing, is 7.5, and this is 7.5, and you add the two 7.5 together, you get 15, and you get 15 minus 15, you get 35. So you get this dimension here. Okay. Now going on to this dimension, and this dimension is one of the toughest to figure out. And let me try. To understand this dimension, let's see, how can I best do this? Okay. This dimension is the dimension that is between these two screws. Okay, between where my two fingers are, between these two screws. And this dimension is the toughest to figure out because it is dependent, I say again, these two screws, it is dependent on the distance between these two gears. Okay? The distance between these two gears. And these two gears are mounted on the side plates or connected to the side plates. Alright? And then we need to find out what these dimensions are. Okay? So what I'm going to do is that I'm going to attempt to draw it over here. Yeah, let me see. Let me look at another. Okay, yes, I think I'll attempt to draw it over here. Let's say you are looking at, how should I look at it? Okay. Let's say you're looking at the, what you call that, catapult from this view. Okay? And I'm going to draw, hang on for a second, This design has changed a little bit. I want to make sure that okay. 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 Let's just see. Okay. I'm going to draw. I'm going to attempt to draw. This is the base plate. Okay, and this is the small little plate, and then there is a big plate. Okay, Ken? And then there is the center of this here is where we have the gear. And somewhere at this position here, we have the other gear. Okay, it's a bit lopsided. Alright, and I'm going to zoom in so that you see it. Okay, and you're looking at it. Well, it's kind of reversed because I'm pointing, I kind of drew it the other way around. But the big gear is here. Okay? The big gear is here, and the small gear is here. Alright? Are you all clear so far? Okay? Now, what we're trying to find is this distance here. This screw hole and this screw hole distance. This distance is the dimension number. This is your dimension number 5. Okay? That's what we're trying to find. Alright? Now, how do we go about finding this distance? It actually all starts from the way the two gears mesh together. Okay? When you have a gear, now I'm going back to the front page. I'll go back later. you have this page here, and it talks about the module of a gear. The module is the terminology that is used to describe the size of the gear, or the size of the gear teeth to be more specific. Okay? The bigger the module, the bigger your gear teeth will be. Clear so far? Okay? Now, what happens is that there is a bunch of formulas here, and it looks really complicated. But the most important formula is actually here. The module is equals to the diameter divided d divided by z. D is your what we call the reference diameter, or the PCD, pitch circle diameter. And this pitch circle diameter is actually this diameter that is in this, or I'll say this diameter over here. Okay? And if you look at this picture, it's the diameter that is between the gear teeth. Alright? It's not at the root of the gear, it's not at the top of the gear, it's somewhere in between. Okay? And that is the what we call the pitch circle diameter. And it is where the mating gear would be touching. Okay? So when we draw the 2D of two gears meshing in mesh, we draw the two PCDs touching each other. Clear so far? Any questions? Good. Now, what happens is that once you know the PCD of the two gears, you would be able to find the center distance of the gear. Agreed? Agreed? Good. Now, the first question is, what is the PCD of the smallest gear? Can someone tell me? I bet you didn't think that today's lesson will be so much questions from the teacher, right? But that's the way I teach. I ask questions and then you give me the answer, and then we figure this out together. Okay? What is the PCD of this gear? Pitch circle diameter. The answer is here in this drawing. Can anybody make a guess? From what I explained earlier and what I showed.
32.
Very good. The PCD is actually 32 mm. Now, if the PCD is 32 mm and the number of teeth is, how many? What's the number of teeth for this gear? By right, like you should have, it's got 16. So if the PCD is 32 and the number of teeth is 16, what is the module of this gear? 2. Very good. The module of this gear is 2. Now, if the module of this gear is 2, the mating gear, must it have the same module or different module?
Same.
Very good. It has to be the same module, because if it's different, you won't be able to mesh properly. Okay? And the PCD of this is 32, which means to say that if I were to zoom in, and I were to put this diameter 32, and I'll put this. What's the PCD of the large gear? Diameter what? Can someone tell me? Sorry? The big gear. Can you all click to the big gear?
48.
Yes. What's the PCD? There are a lot of numbers there. Is it 10?
He said 48.
Who?
48.
48. Very good. It's 48. Now, if it is 48, right? what is the center to center distance between the two gears? This dimension here. What is this dimension? Somebody said something? 40. 40 is your answer. How did you get 40? 16 plus 24. You get the radius of the smaller gear, the smaller PCD, the radius, plus this radius here, right? So it's 16 plus 24, it is 40. Now if you know that this is 40 mm, if you know that this is 40 mm, are you able to find out what this dimension is? This is the time where I will go to food court 4 and order a cup of coffee, and then I will drink there for like maybe 20 minutes. And then when I come back, you all will magically give me the answer. Is it?
Yeah.
Yes. Alright, awesome. Okay? No, I won't do that. That's too cruel. Okay? I know you guys are hungry, but unfortunately we are not allowed to go to the food court for this. Yeah, we are not. The only specified class can go there from lunchtime from 12 to 1 o'clock. Yeah, if you need to eat anywhere, you bring your own, buy your own food, you bring here. I will allow you to quickly put it in your mouth discreetly somewhere, right? Oh shit, it's recording. You didn't say that. I didn't say that. Jeez, I feel like Donald Trump all of a sudden. On the camera saying the wrong things at the wrong time. But yes, I will give you 10 minutes to try and figure out from here, because you know that the distance is supposed to be 40. How do we then find out what is this distance that it should be? Okay? I will give you a hint and tell and explain to you how to go about. I give you a small hint, okay? So I don't spoon feed you all the way. You need to look at the 2D drawing of the motor plate first. And from the 2D drawing of the motor plate, you need to find this dimension, the center where the gear is being mounted, to the mounting point over here. Once you have this dimension, you will get this dimension. And then you will find the center of this, right? Where the gear is mounted to the mounting point of this gear, and then you will find this dimension. Let's call this dimension A, and this dimension B. Okay? When you get dimension A and dimension B, you will know that this dimension here is 40 minus A minus B. Then that's it. Okay? Now this is a very big hint. But how do you go about finding these dimensions is something which I need you to work it out, and I need you to tell me. Alright? Hey Jonathan, long time no see. Yes, disturb my class. Okay, so I'm going to put here dimension A, this dimension B. Okay, we need to find these dimensions. And once you find this dimension, you'll be able to find this. Alright, I give you all 10 minutes. If you need to drink water or anything, just go ahead and take your sip. If you have a light snack, you need to pop it into your mouth, please go ahead and do it. Okay? going to attempt to drink some water. Now let's all work together. Let's try and find dimension A first. Are you able to tell me what dimension A is? To find dimension A, you need to look at this drawing. Woo. This drawing here. Can someone tell me what is this dimension? From this, because this is where the motor is mounted, this will be in the center of the gear. Okay? Then what is this from this dimension to this dimension? What is this dimension? Anybody? Use your brain juice. This dimension from the center to this center. What is this dimension? Yes, sorry? I thought you raised your hand.
Yeah. I think it's 8.5.
8.5. Wrong.
So it is 17.5.
Sorry?
17.5.
17.5. Now, how did this young lady get 17.5? Can you explain to us?
25 minus 7.5.
Very good. She knows that the width of this whole entire plate is 50 millimeters, right? And half of this plate is actually from here to the edge here is 25 millimeters. So you know also that from this edge to the center of the hole is 7.5. Take this 7.5 and put here. This is 7.5. So therefore 25 minus 7.5, you get 17.5. Correct? So if I were to come back here and I can't find my pen. Where's my pen? Okay, I think I'm suffering from dementia. Let me zoom in. How did that pen disappear? A is equals to 17.5. Okay? Did you all see? Do you all have that down, recorded? Now what is dimension B? Dimension B, unfortunately, is a little bit trickier. Now if you look at this plate, This plate is what I call a holy plate. It's got a lot of holes, right? Now, one of these holes is where the big gear is going to be at the center. Which hole would it be? Which hole it will be? To find out which hole it will be, you need to look at the assembly drawing. And assuming that this plate is now, because we drew it this way, this plate now is in this orientation. Okay? And it's somewhere at the bottom left-hand corner. Bottom left-hand corner. It's somewhere here. Alright? Somewhere here. Sorry, I don't know where it's put. Somewhere here is at the bottom left-hand corner. Somewhere around this region, but we don't know exactly which hole. Can you look at the assembly drawing and pinpoint the hole that the big gear will be at the center of? Where would it be? Yes, very good. Can you point out where is it? Come, step forward, don't be so shy. You point there and draw. You help me there. Wrong. You need to flip your brain around. Bottom left. So look at your assembly drawing again and see where would that gear be. Where would that hole be? Can I have another volunteer? Yes. We maintain the 1 meter safe distancing. Ah, very close, but no, not where you're pointing. Where is it exactly? Which hole? Sorry? No, it's not this one. You can go back to your seat. When you look at your assembly drawing, the way I've sketched it out is the reverse of the drawing that you are seeing, okay? So you need to reverse the drawing. So which hole is it that you are calculating from? Because I drew the drawing in the opposite way. So which hole would it be? Can I have you? What's your name? Akil.
Is it there?
Yes, come point exactly. Yes, very good, Akil. This is the one. Okay? This is the one that we're looking for. And that is the hole where the big gear is going to be sitting on. Okay? And then if you were to extend this line, what is this distance here? What is that distance there? Can someone tell me? This 13 TYP here is 13 mm. So this distance here is 13 millimeters. 1, 3. So what is that distance at the bottom? 4.5. I'm not sure. How do you get 4.5?
Take 50 minus 10 minus 7.5 minus
50 minus,
15, which is the 10,
okay,
minus 10, which is from the center to the edge.
okay. So it's 25.
Yeah, then minus 7.5.
Then minus 7.5,
Yeah,
okay.
and minus 13, which is the space there.
Okay. Then what's the number again?
4.5.
4.5. Anybody disagree? Can someone second check check the number and confirm that it's 4.5?
4.5.
4.5, confirm?
Yeah.
Because 4.5 plus 7.5 plus 13 is 25 mm. Correct? Right? So it's 4.5. Now, if we were to go back to that small Toria, not COVID. That's what they all say. Where's mine? Damn, your drawing is gone. Small beer. Let's zoom in. So B is 4.5 mm. So if B is 4.5 mm, then what is this distance here? 2. What is that distance? 1/8. So this distance here is 18 millimeters. So 18 plus 70.5 plus 4.5 gives you 40. Is that true? Can you verify that? Correct, right? 22. Then after that, you pass the 2 over there, you get 40. Okay? Now, can you see how painful it is to just do this simple design? Okay? So please don't underestimate when you are doing your design work. There is actually a lot of calculation that goes on. Although the calculation is not very complex like differentiation or integration, but it goes back to the understanding of how the gears mesh together and mate. Then you find the center distance, and from the center distance, you dictate how they are being mounted on the side walls, and from the side walls, you then determine what is the distance between the two screws. Okay, so that is very important. And finally, the number here is 18 millimeters. Okay. Now, what is the next dimension that you should be figuring out? The next dimension you should be figuring out is, whoops. Are these 4 holes over here? Okay, and these 4 holes are shown on the catapult, and these 4 holes are for mounting it to this base. Okay, so you have this base and this catapult, and you need to mount it. Okay, the drawing shows. Wait, hang on for a second. Okay. The drawing shows that it's mounted this way. And you need to determine the 4 holes. Okay? But however, personally I find that if you mount it this way, given this structure that we have, it's better if we rotate it by 90 degrees, okay, and have the motor on the outside, right? And what we're going to do is we're going to line up the 4 holes, and then we need to put the dimensions of these 4 holes on the plate so that we can make them. Okay? But what are the dimensions of these 4 holes? Right? It would depend on how this goes onto this plate here. Okay? Alright. I think I will stop here for today. Alright? I'll stop here for today, and I would let you all, when the build, next 2 weeks later when you come back, some of you may be 3D printing. We will then start to evaluate how we go about doing this. Alright, 2 weeks from now I will give you the metal plate, and then we can start marking out. Okay? And then we will determine this, and we will also work on the C channel. Which is here. The C channel is this C channel here. You will need to determine dimension A, dimension B, and dimension C. And I'd like you to try and figure out what these 3 dimensions are on your own. And then next week when we come back, we can try and discuss it. Okay? This is the block that would fit into the C channel. This is the block. When you look at the assembly, you will see this block here, and you will see the C channel going to this block. So you need to determine what these dimensions are. Okay? And I'd like you to do that on your own. Okay? It's pretty straightforward. You need to have some visualization. And next week, 2 weeks from now, when you come back, we will go through the dimensions, and then we can start marking out, and we can start drilling the holes. Right? Now, next week you won't be coming here. Next week, yes, you'll be coming here. Next week you will need to go through the 3D printing e-learning, the Blackboard. Try and pass the quiz, get 80 points and above. Download the projectile seat and the projectile, so that next week when we come, you all can start 3D printing. Not next week, sorry. 2 weeks from now when you come back, we can start 3D printing. Got it? Got it? And then, while it's 3D printing, we can verify the dimensions, okay? And we can start to mark out, and we can start to drill. Okay? There are 2 drills in this workshop. There's one over there, and one at the back. Okay? And there will be more than enough for us to work on it. Okay? Because there are only 3 groups. Usually, one group will be slower in marking out, and then, yeah, it will take some time to drill. Okay? In the event, if I can, I would, if I have the bandwidth, I'll try and see if I can accelerate this group, this class here today, by passing you more information such that maybe when you come back 2 weeks from now, we are ready to mark out and do the drilling. Okay? Right? So I'll try to think of a way where we can work on this together. Alright? We'll communicate via WhatsApp. Now, the module coordinator may not have printed enough for everybody, so I may need to take back some of the notes. So each group takes 2 copies. Can? Yeah. Oh, then never mind, just take one. Okay. Thank you so much for your attention today. And I'll see you 2 weeks from now. Except for you, I'll see you next week. Yes. Okay, I need to stop the video.